about the relationship between delta H, that is enthalpy of the reaction, and delta U, that is internal energy of the reaction. See, so we will be finding out the relationship between delta H and delta U when both reactants and products are in the gaseous phase. Reactants and products are in gaseous phase. So, relationship between delta H and delta U when both the reactants and the products are in the gaseous phase, right? So, we have a reactant gets converted into product, yes. So, we have this formula delta H is equals to delta U plus P delta V. We had discussed this formula in the previous lecture. Now we know that ideal gas equation, chapter 5, states of matter. So what is ideal gas equation? Ideal gas equation is when PV is equals to nRT. So if we differentiate this equation at constant pressure, it will be P delta V is equals to delta N RT. Why? Because R and T are constant, and since we are saying that both the reactants and products we have to take them in the gaseous state, so we'll write it as P delta V is equals to delta Ng, that is number of moles of gaseous reactants and products is equals to delta Ng RT. So we can write this as delta H is equals to delta U plus P delta V, we can write it as delta Ng RT. This is how we have to write this equation. Yes? Okay. Now what is this? Sometimes it will be given to you that because delta H, delta U and delta E are one and the same thing. So sometimes you will find that in some of the books they write it as delta H is equals to delta E plus delta Ng RT. It's one and the same thing. So you don't have to get confused with it. Now what is this delta Ng? It's number of moles, change in number of moles, yes, in gaseous phase. So it is number of moles of product in gaseous phase minus number of moles of reactant in the gaseous phase. R, what is R? R is a constant, gas constant, and temperature, we have to take the temperature in Kelvin. Using this formula, we will be now solving some questions based on this formula. Okay. Suppose if I give you some reactions and you have to find out, tell me whether, I'll give you some chemical reactions whether delta H is greater than delta U or delta H is less than delta U or delta H is equals to delta U. We have to find out these things, right? So suppose we have this equation, nitrogen gas plus 3 moles of H2 gas gives us 2 moles of NH3 gas. So in this equation, find out the value of delta Ng. It's 2, in product we have 2 and reactant is 4. So minus 2, and delta H is equals to delta U minus delta NgRT. Yes, or you can write it as plus NgRT, so delta U minus 2RT. So delta H is less than delta U. Right? Suppose we have this equation H2 gas plus Br2 gas gives 2 moles of HBr. Now delta Ng in this will be, the value of delta Ng will be 0, and so delta H is equals to delta U plus delta NgRT. Since delta Ng is equals to 0, so therefore delta H is equals to delta U. This is how we have to do these questions, right? Suppose, let us discuss another case also where delta H will be greater than delta U. Like suppose we have magnesium carbonate, it's a solid, and on heating we'll get magnesium oxide, which is again a solid, plus carbon dioxide gas. Yes, so delta Ng will be equal to 1, right? So delta H is equals to delta U plus 1 RT. Therefore, in this also delta H is greater than delta U. This is how you have to do these questions. Okay, suppose next question we have this question: find the value of delta H minus delta U for the reaction. Yes, and what reactions? In terms of RT, we have to find out the value of delta H minus delta U in terms of RT only, right? And the chemical equation which they have given is 2 moles of C6H6, this benzene, reacts with 15 moles of O2, which will give us 12 moles of CO2 gas plus 6 moles of water. So we know that delta Ng is number of moles of product minus number of moles of reactant, and they are in gaseous phase. So 12 minus 15 is equals to minus 3. So delta H is equals to delta U plus delta NgRT. You should write the formula again and again so that you will never forget. If you will keep on writing the formula again and again, you will never forget the formula this way. So this is how, this is the answer, minus 3 RT, right? Okay. Next we have, see, we know that delta H is equals to delta U plus delta NgRT, right? We can also add that dH is equals to du plus delta NgRT. And what is this? dH is Qp, heat content at constant pressure, is equals to heat content at constant volume plus delta NgRT. Like suppose instead of delta H and delta U, they give you heat content at constant pressure and heat content at constant volume. So in that case you have to apply this formula. Okay. So let's do one numerical on this formula so that it will become more clear to you, like what kind of questions or what kind of numericals come in the exam. So the question is, we have the question. The question is, find the difference between heat content at constant pressure and heat content at constant volume. Find the difference between the heat content at constant pressure and heat content at constant volume at temperature T. At temperature T. And the reaction which they had given to us is C3H8, that is propane gas on combustion. It will give us 3 moles of CO2 gas plus 4 moles of H2O liquid. So let's try to find out the value of delta Ng. What is delta Ng? 3, because 3 moles of CO2 minus 5 moles of oxygen. It's minus 2. And we know, see, they have asked us find out the difference between heat content at constant pressure and heat content at constant volume. See, Qp is equals to Qv plus delta NgRT, right? So therefore Qp minus Qv is equals to delta NgRT. What is delta Ng? It's minus 2 RT. Yes, and if you try to solve it, it will be minus 2. R is 8.314 joule per Kelvin per mole into temperature is temperature T. Suppose temperature they have not, it's T, or you can say suppose temperature is, suppose it's 27 degrees Celsius. Means 27 degrees Celsius means it's 300 Kelvin, right? What is it? 300 Kelvin. Let's put it 300 Kelvin. So this Kelvin gets cancelled. We get minus, and this, wait, 1000. So it will be 3 to the 6, 83 1.4 joules. Or else we can find out the energy also in kilojoules, depending on the options given to us. Thank you so much.